Bar magnet, definition, types, properties, uses, field lines, magnetic field. What is magnet? A magnet is any object which is capable of producing magnetic field outside itself and which attracts other ferromagnetic materials like iron, cobalt, nickel, copper, etc. This magnetic field produced is invisible, but it is responsible for the most notable property of a magnet, i.e., it attracts materials and attracts or repel other magnets. Magnets can be ramified in different types on the basis of their shapes. For example, bar magnets, horseshoe magnets, cylinder or disc magnets, drum magnets, etc. Types of magnet. 1. Natural magnet. Magnets that are available in nature are called natural magnet. They possess relatively weak magnetic abilities and do not strongly attract ferrous materials. An important example of a naturally occurring magnet is a lodestone. In comparison to artificial or man-made magnets, natural magnets are much weaker. 2. Artificial magnet. Magnets produced by humans by applying scientific magnet developing technologies are known as artificial magnets. Such human-made magnets have the ability to create a relatively stronger magnetic field. One can make artificial magnets in different shapes and sizes. A magnet, which is shaped in the form of a rectangular bar, is known as a bar magnet. Properties of bar magnet. It has a north pole and a south pole at two ends. Even if we break a bar magnet from the middle, both the pieces will still have a north pole and a south pole. The magnetic force of it is the strongest at the pole. If two bar magnets are placed close to each other, their unlike poles will attract and like poles will repel each other. A bar magnet will attract all ferromagnetic materials such as iron, nickel and cobalt. Magnetic field lines around a bar magnet. The magnetic field lines area a set of imaginary lines that can be drawn along the magnetic field that is acting around any magnetic substance. The magnetic field lines possess certain properties. They are mentioned below. The magnetic field lines of a magnet form continuous closed loops. The tangent drawn to the field line at any point represents the direction of the net magnetic field B at that point. The more is the number of field lines crossing for any defined unit area, the stronger is the magnitude of the magnetic field B. The magnetic field lines never intersect each other. Uses of bar magnet. Bar magnets are used as stirrers in laboratory for magnetic experiments. They also find applications in medical procedures. Electronic devices such as telephones, radios, and television sets use magnets. Many industries use bar magnets for the collection of loose metals and iron scrap and also for retaining magnetism of existing magnets. Pole strength of magnet. Pole strength can be defined as the strength of the magnetic pole to attract magnetic materials towards itself. Pole strength is a scalar quantity. The formula for calculating the pole strength is as follows. P equals Y, where P is the strength of the magnetic pole. W is the work done while moving the magnet around the wire. I is the electric current in the wire. Types of bar magnets. 1. Cylindrical bar magnet. The cylindrical bar magnet is also often known as a rod magnet, as it looks like a cylindrical rod. The thickness of such a magnet is larger than its diameter, and thus, it has the ability to increase its magnetism. A cylindrical bar magnet is primarily used for educational, scientific research and experimental purposes. 2. Rectangular bar magnet. As per the name, a rectangular-shaped bar magnet, which has two poles and the ability to create a relatively strong magnetic field, is known as a rectangular bar magnet. Such a magnet is mainly used for product manufacturing purposes in all engineering sectors. 3. Alnico bar magnet. The primary components of Alnico magnets are aluminum, nickel, cobalt, and iron. These magnets produce a strong magnetic field and retain their magnetic property even when subjected to extreme heat. 4. Neodymium bar magnet. Neodymium bar magnets are made with a mixture of neodymium, boron, and iron. Despite being brittle, these magnets are incredibly powerful and capable of producing a stronger magnetic field. Thanks for watching.